All right, so let's look at an analysis of what's going on here. If we look at just the dot diagram first, you'll notice that the change in position of the ball every 5 frames is increasing. So the amount of distance it covers every 5 frames is changing. So you might recognize that it's changing speed then, right? So this dot diagram is showing us this object is speeding up. And if we look at a position time graph, it should show us the same thing. And so if I look at my position time graph here, I'll see that, so I'm no longer interested in the x. So first of all, let me hide that. I'm only interested in up and down motion, which is the y dimension. And so if I look, it appears as if this is no longer a linear line. So if I try to apply a curve fit, these data points don't really fall in this line, which makes sense because these objects aren't really changing by the same amount of position every second. It's not moving 2 meters every second or 3 meters every second. It's speeding up. And so it's also the positions are getting more and more negative. And so what you want to do here is not apply a linear curve fit. In math class, you might recognize this as a quadratic equation. So quadratic or like a parabola. And now if you look at these points, they all fit on that line perfectly. And so the position time graph for an object that's speeding up should look something like this. The slope, which is the speed, should not be constant. It should be changing. And if it's speeding up, it should be getting steeper and steeper and steeper. And so if I look here, you might see this graph and not be comfortable with it because it's speeding up in the negative direction. So what I can actually do is I can go to System. So let me just look at my video here for a second. I can go to System and I can change my origin because right now y is upwards, which means positive is upwards. But if I rotate this so that the y is down, it's going to make it so that the vertical dimension is, so that the downwards dimension is positive. So when my ball is moving in the y, it's going to think that it's moving in the positive direction. So let me do that. Okay, so now I've rotated it, made sure it's still vertical. Let's play the video. Yeah, it looks pretty vertical. If I show my graph, look at that. Now the object is moving in the positive direction. The positions are getting more and more positive. And if I look at my velocity, so if I just look at the data table, I will see the y velocity, which is what I'm interested in, up and down. It looks to be changing. It goes from 3 meters per second in the beginning to 13.78 towards the end, right? So it's definitely speeding up. And with things that are falling, because they're speeding up, we can analyze their motion. We can see how much are they speeding up every second. Is there a pattern to that? So in order to do that, I'm going to hide my video here, and I'm going to go to graph, and I'm going to show 2 graphs this time. And I'm going to hide my data table for now. But I want to show, see what the velocity is over time. And so I don't care about the x velocity. I'm going to hide that. I'm going to show only the y velocity, y up and down. And so if I look at those data points, it looks to be that the velocity is definitely changing. And the pattern it looks like is it's pretty linear, right? These data points, if I was to create a best fit line, look to be pretty linear. And so I'm going to apply a curve fit here. And they all more or less fall on this line. So it does seem like linear is pretty good. And so when I look at a slope like this, I can see, okay, the speed is changing the same amount, or the velocity is changing the same amount every moment in time. The slope is constant, right? The slope is telling us how much is the velocity changing per second. So if I look at this value, 9.765, I'm going to round that to 9.8. That's telling, the slope is telling us that 9.8 meters per second, that's how much the speed is changing every 1 second. So after 1 second, it's going to be going this fast. If it starts at 0, after 2 seconds, it's going to be going double that. So after 2 seconds, the ball should be going 19.6 meters per second. After 3 seconds, it's going to be going 3 times that. That's how much it speeds up every second. That's what the slope of a velocity time graph tells us, right? So it's interesting. The ball speeds up at a constant rate. Something to keep in mind. That is going to be true for all falling objects. They all accelerate at a constant rate.